Good morning. We're looking at homework 7.10. This is homework that was assigned Friday, so we're going over some of the questions that were asked in the Google form. So we're solving exponential and log equations, and the first one we're going to look at is number 4. So one of the kind of hints I see in number 4 is it has 3 terms, and it's set equal to 0. So that tells me I may want to try factoring, but before I do that, I want to manipulate this a little bit. So 3 to the 2x could be written as 3 to the x quantity squared, because power to a power I multiply. And then for this middle term, I see 3 to the quantity x plus 1, so I think about how did I get that? So I know that when I add my exponent, it means that I have multiplied like bases. So actually, 3 to the x plus 3 to the, or times 3 to the first, if I multiply like bases, I add my exponents, that would give me 3 to the x plus 1, and then I've got minus 4. So, you know, if you wanted to, if it helped you see this, why don't we plug u in for 3 to the x? So if I do that, I would have u squared plus u times 3, so let's write that as 3u minus 4. Which factors using trial and error. Set each factor equal to 0, and I get negative 4 and 1. And so now I'm going to go back and plug in. That means 3 to the x equals negative 4. 3 to the x would equal 1. That's an exponential equation. I'm going to go ahead and change that to a log. So I would have ln. Change my mind. I'm going to take a base of 3 log base 3 of negative 4 equals x. That can't happen, so that's an undefined operation. And then I would have log base 3 of 1 equals x. Well, I mean, I could actually go back and look. What would x be to make this happen? What is log base 3 of 1? It's 0. And so there's your one solution. Okay, let's talk about number 6 for just a minute. And I've mentioned last week on Friday, there are several different ways to work this problem. And one of the things I see here is that I have a base of e, and so that tells me I want to use ln's. And so what I'm going to choose to do is take the natural log of both sides. And again, this is just one way to work this problem. By the power property, I can bring my exponents out front. And when I do that, ln of e, that's 1. That is 1, because it's a base e. So I don't have to worry about that anymore. I know ln of e, and let me write that to the side, is 1. So I'm going to go ahead and distribute ln of pi. So we'll have ln of pi minus x ln of pi equals x now. So I need to get my x values on the same side, so I'm going to go ahead and do that. Ln of pi will equal x plus x ln of pi, and I need to get x by itself, so I'm going to factor an x out. And then just divide. So ln of pi over 1 plus ln of pi would equal x. And so again, as you're checking your answers, let me pull up my answer. What I had is the answers here. I gave it to you as a decimal, so you can certainly check in your calculator that you have the right solution, because there are multiple different ways to work this problem. And I got x equals 0.534. I would be perfectly fine with your leaving your answer as a log. There's nothing wrong with that. Okay, the next one that I had some questions on is number 8. So as I look at number 8, I see all of these logs have different bases. So that kind of lets me know where to start. Let's start by making the bases be the same. And so in order to do this, I'm going to choose to write everything with the smallest base. So let's convert log base 16 of x to a log of 2. So by change of base formula, this is log base 2 of x over log base 2 of 16. Log base 2 of x over log base 2 of 4 plus log base 2 of x will equal 7. So actually I'm glad I chose log base 2 because log base 2 of 16 equals something. If I convert that to an exponential, 2 to the something is 16. What is that something? It's 4. So log base 2 of 16 is actually 4, so I wrote that as 1/4 out front. Log base 2 of 4 would be 2. So I have log base 2 of x. You can write that all over 2. I'm going to use 1/2 out front. And log base 2 of x equals 7. So now actually let's add. How many log base 2 of x's do you have? So I'm really just adding like terms. Here I have a 1/4, here I have a 1/2, and here I have 1. So let's add all those together. So 1 plus a 1/2 is 3 over 2. 3 over 2 plus 4 would be what? 7 over 4? Now let's just get the log by itself. So I'm going to multiply both sides by 4/7. So I get log base 2 of x, and on this right-hand side, I'm just left with 4. Now we have a single log statement, so let's turn it to an exponential. 2 to the 4th equals x, so that means x is 16. And that would not cause any domain restrictions. The only domain restriction I would have is x had to be greater than 0 because that's what each argument is. All right, let's go back and look at problem 18. So as I organize my thoughts for 18, I see I have two terms set equal to 0. And so when I see things set equal to 0, my mind always thinks about factoring. And your first step of factoring is GCF, which you have one here. Your GCF is x, which will leave you with 2 ln of x plus 1. So I set each factor equal to 0. There's one solution. I have to check that. By solving the other, I end up getting ln of x equals negative 1/2. So let's change that to an exponential. The base of ln is e, so it'd be e to the negative 1/2 would equal x. And depending on how you write your answer, that would be okay. You could write that as 1 over e to the 1/2. You could write that as 1 over the square root of e. You could even rationalize that and say square root of e over e equals x. I mean, all 4 of these are an equivalent number. So let's go back and make sure we don't have any domain restrictions. So my only thing I need to worry about is ln of x, and so that means x has to be greater than 0. So actually, we do have one extraneous solution. All right, let's look at number 20, which number 20 is another one. I gave you a hint and said, be sure that you change your base. And so kind of like the other problem, I'm going to stick with the lower of the bases. So I'm going to stick with a log base 2. And when I use change of base, I like that because log base 2 of 4 is 2. That is 2. So I have log base 2 of x squared plus 1 minus, let me write this as 1/2 out front. Log base 2 of x squared. Well, let's use power property this time, and I can't get the log by itself quite yet or combine these. I've got to use this power property. So that means I have log base 2 of x squared plus 1 minus log base 2 of x squared to the 1/2 equals 1. I can now use quotient property. I'm subtracting 2 logs, so I know that I can write that as division of logs. So I have log base 2 of x squared plus 1. This is really like taking a square root. So the square root of x squared is absolute value of x will equal 1. So from here, I'm having to grab another sheet of paper. I need to change this to an exponential. So I have a base of 2. 2 to the first will equal x squared plus 1 over the absolute value of x. I'm going to multiply both sides by x. And since I have absolute value, I know that that ends up meaning that I will have a piecewise. And so my 2 pieces will be x if x is greater than or equal to 0, and negative x if x is less than 0. By the way, let me go back for just a second. The domain of log base 2 of x squared plus 1, that's actually all real, because x squared is always going to be a positive number, or 0. So you will never get a negative quantity in this problem. And in the other log, the same thing happens. X squared, the only restriction you would have there is x cannot equal 0, because that would cause a log base 4 of 0. So just kind of watch out for that. And so that's why you still need your piecewise, because you will end up using both pieces to solve here. So my first piece will just be 2x equals x squared plus 1. And my other equation will be 2 times negative x equals x squared plus 1. So I do have a quadratic. So for the first, I get x equals 1. Okay, let's go with the other. So I'm going to set this equal to 0. I get x squared plus 2x plus 1. So x equals negative 1. And actually, both of those are a solution. So I actually see a mistake on my answer key. The solution should be 1 and negative 1 there.